Now let's talk about how to use the advanced programming mode to program custom sequences into the Hydra sequencer. You will need either a laptop or a desktop computer and a USB cable to communicate with the Hydra sequencer. Additionally, you will need to install some software that allows your computer to effectively communicate with the Hydra sequencer. Now there are several different software options that allow you to communicate via USB interfaces. However, we recommend that you use the Arduino Integrated Development Environment. The reason we recommend using the Arduino software over other software suites is because the Arduino software is very well documented and well supported. If you run into any technical problems, you can find answers to just about any question on their website. So let's take a look at how to download and install this software. So let's go to the Arduino homepage. That's www.arduino.cc. Once on the home page, we're going to click on the Download tab. Once on the download page, scroll down to find different options depending on your operating system. In my case, I use a Windows machine, so I'm going to click on the Windows installer. This will begin downloading the software. Be patient, as this will take a while. Now, depending on your internet browser, you may have to double-click a file after you download it, or if you're using Internet Explorer, it should start automatically. Once the download is complete, you will be prompted with a security warning. Go ahead and click Run. This will begin the installation process. Go ahead and click I agree to the license agreement, then click Next. And finally, you can choose a location where you would like to install the software. The default location is under the C drive in Program Files and Arduino. If you are happy with this location, go ahead and click Install. Again, be patient, as this may take some time. Once the software has been successfully installed, we can go to the location where we installed it. In my case, that was under C, Program Files, Arduino. Inside this folder, we see an executable with an icon that says arduino.exe. At this point, we have a couple of choices. We can pin this to the Start menu, create a desktop shortcut, or just open the software from this folder. I'm going to open it directly from this folder by double-clicking on the icon. You will see a window like this one pop up. Here I have maximized the window. Now before we can begin programming the Hydra sequencer, we need to take care of a few details. First, we need to install the drivers that allow the computer to communicate with the Hydra sequencer. In the case of Windows machines, this should be done automatically as soon as you plug in the sequencer. So go ahead and plug it into the computer. You should see a balloon that pops up and says, "Found new hardware, USB serial port," and it'll take a few seconds and then it will say that your hardware has been successfully installed and ready to use. If you're using a different operating system or if you run into any trouble installing the drivers, please refer to the Arduino website. Under the Getting Started tab, you will find information on how to manually install drivers for different operating systems and possible problems that you could run into and how to work around them. Once the drivers have been successfully installed, we need to determine which serial communication port the computer will use to talk to the Hydra sequencer. The best way to do this is to unplug the sequencer, go back to the Arduino window, click on Tools, Serial Port, and note which ones are currently available. On my computer, the ports COM1 and COM3 are always available. Now I'm going to X out of that window. I'm going to plug the Hydra sequencer back into the computer. Now again, I'm going to go to Tools, Serial Port, and now I see that I have a new port available. I click on the new one. That's the one that I'm using to communicate with the sequencer. Now I need to tell the software which board we're communicating with. We will again go to Tools, and this time we're going to click on Board, and then scroll down to find Nano. Now depending on the version of the software that you have, you may see two different options for the Arduino Nano. For instance, you may see Nano with ATmega 328 and Arduino Nano with ATmega 168. In the case of the Hydra sequencer, we use the ATmega 328, so that's the board that you should select. Now that we're all set up to communicate with the sequencer, let's click on Tools and Serial Monitor. You're going to see the following window pop up. From this point, you have approximately 5 seconds to give it an input. If you do not give it an input within 5 seconds, the Hydra sequencer will continue with its boot, and you will be unable to communicate with it. Notice the small square character at the bottom. This appears after 5 seconds and indicates that the serial connection has been closed. If you see this, you will have to close the serial monitor and reopen it to reset the Arduino and try again. Notice that you have a couple of options for inputs. You can either send the character D to change the dwell time, or you can hit the character S to enter sequencer mode and program a custom sequence. Okay, so I'm going to go ahead and restart my serial monitor, and then we'll go into sequencer mode. So I send the character S by typing S and clicking send or enter. And now I'm in sequencer mode. Notice that it asks for time steps entered in milliseconds, separated by commas, and bracketed by parentheses. So I'm just going to start putting in some random values for time steps. Now before we mention that we have to make certain time steps 1/2 of the dwell. Now the computer will take care of this automatically. If I accidentally put in a time step that is less than 1/2 of the dwell, the software will automatically change it to 1/2 of the dwell, and we'll see how that works here in just a minute. Okay, so I'm happy with this for a random sequence. I'm going to go ahead and click send, and notice that it basically spits out everything I just typed in. This allows me to go back over and make sure that I've entered in all the time steps the way that I want them. Now if I'm happy with it, I can click S to save, or if I'm not happy with it, I can hit A to abort. And when I abort, it automatically resets the software, so I begin again at the beginning. So let's go ahead and take a minute to read through this. So we see that the first Q will fire as soon as the stepper input is pulsed. Q2 fires 500 milliseconds after the previous Q. Q3 fires 500 milliseconds later. Q4 500 milliseconds later. And Q5, because it has a value of -1 milliseconds, will wait until it receives another input pulse before it begins firing the next sequence. Notice that the next sequence is not exactly how I've entered it. The time step for Q7 and the time step for Q13 is different from what I entered. Because the factory set dwell is 100 milliseconds, the software has automatically changed the time step for Q7 and Q13 to 50 milliseconds. Now if I had had a time step there that was greater than 1/2 of the dwell, it would have taken that for a value. But because I entered 10 milliseconds and 1 millisecond, the computer recognized that this could be an error and automatically changed it to 50 milliseconds. If you change the dwell to say 1 second, then those time steps would be automatically changed to 1/2 second, and etc. Now let's close out of that and see what happens if we don't enter any time steps at all. So I reopen my serial communications, I hit S for sequencer mode, and now I'm just going to enter an open parenthesis and a closed parenthesis. Notice that that automatically stores a -1 value for each of the time steps, thus putting the sequencer into stepper mode. Now I'm going to hit A to abort, and notice that it restarts my serial communication. Again, I'm going to send S to get into sequencer mode, and then I'm going to type in another random sequence. Okay, so let's do a couple of 100s, maybe some 50 millisecond time steps, some 10 millisecond time steps, and let's put in a -1 and maybe some half-second time steps. Okay, so I hit enter, and it spits out basically what I just typed in. This allows me to review it and make sure that everything looks good. Now I'm pretty happy with this, so I'm going to go ahead and click S to save it. I would like to point out that Q13 is -1. Notice that this is not equal to 1/2 of the dwell, but because it's waiting for an input pulse, the software allows it. Okay, so now we have the sequence successfully saved. Let's see what that looks like on the actual Hydra sequencer. Okay, so here I have the Hydra sequencer. It's currently armed and waiting for an input pulse. Now again, I have a pair of 9-volt batteries and my simple push-button switch to mimic the input of an existing firing system. So I'm going to go ahead and press my button to start the sequence. Here goes the first part of the sequence, -1. It's now waiting for another input pulse to fire the next part of the sequence. So let's go ahead and hit it again. Here we go with the half-second time steps. It waits again for another input, so I'll give it another input. It fires the last cue, and now all additional inputs will pulse the output, allowing you to daisy chain multiple systems together. Well, thank you for watching the video. If you have any questions, please don't hesitate to contact us.